Confidence intervals for population proportions. You might wonder what that is. Well, it can go back to elections. What proportion of the electorate, for example, is inclined to vote for a certain candidate? Let's see how we can find out some information here. 3 points we want to hit. Of course, a point estimate. What's our best estimate of what that proportion is? How about a confidence interval, perhaps? And before we actually start doing anything, we need to get our minimum sample size before we actually do the sampling. So the probability of a success is P. That should sound familiar. And our P up here is for population proportion. So try not to get the two mixed up. When you actually do this, let me get the pen rolling here. There we go. All right. So we want a sample proportion because we wouldn't be doing all this if we actually knew what P was. So just take the number of people that said, yes, we're for candidate A. Divide that by how many people you surveyed, and that gives you a point estimate. P hat. P hat. So let's start off with an example because, excuse me, this section is pretty easy really once you get the first part down. So we're surveying 1,550 adults. 1,054 said, yes, we use Facebook. Find a point estimate. That should be pretty easy. Just take the 1054, divide by the 1550, and you'll have P hat at 68%. 68% of the U.S. adults, according to our survey, say that they use Facebook for social media. Next, what's the confidence interval look like? This should look very familiar. There's our point estimate before we had X bar, remember? Here's our point estimate. Point estimate minus the margin of error. Point estimate plus the margin of error. Again, very similar. Remember, this is what we don't know. And this is the new guy on the block. This is how we find the margin of error for a population proportion. Z sub C should look familiar. Remember, that's the middle of your picture. P is what you got in your point estimate. P hat. X sub n, remember. And Q hat, because it's just an estimate, is just 1 minus P hat. Very simple. N is your sample size. Very easy calculating. Put that in those two places. Remember that C is in the center of your confidence interval. So find the sample statistics and NX. Get the point estimate. Also very simple. Also, this is new. So write this down on your formula sheet. You do have to check these two off. This is the N we just talked about up here, times that P hat. Is that product greater than or equal to 5? You also have to check Q. Is N times Q hat greater than or equal to 5? If it passes both of those, then you're in good shape. That means your population proportion is approximated by a normal distribution, and we'll be on our way. Number 4, critical value. Remember those critical values in the center help you find what z sub c is. Get your margin of error. Remember, you'll have p hat and q hat. P hat you calculated from your sample. Q hat you calculated from p because it's the complement with the total of 1. And there's your sample size. Very simple, at this point at least. Create your left and right hand endpoints. So what do we have? There's our point estimate for the population proportion of successes. And for the failures, you just subtract p hat from your 1, and there's your q hat. Don't forget that. N is sampling size. Check to see whether that's greater than or equal to 5. Bingo. Way over 5. Good. Check NQ hat. Way over 5 again. You're in good shape. So what we have is something that's very close to a normal distribution. Nothing's perfect, but it suffices. So there's our margin of error. The 1.96 is from the confidence level, using z equals inverse norm. And there's your calculator result. Add that to 0.68, which was the point estimate. Add it, subtract it, you've got your confidence level, or your confidence interval, excuse me. So what do we have? Well, here's another way we can do it. Use the TI-84. Now this might be a very pleasant surprise. For that TI-84, go to Stat. This is a little bit different. This is our first foray into this part of the TI-84. Go over to Tests instead of Calculate. In the Tests menu, pick out A, 1 proportion Z interval. Z interval because we're using the Z test because it's normally distributed. Int because we want an interval. Put the 1054 in for the X. That was in the numerator for our point estimate, remember. Second, put in the size of N, our sample size. Put in the confidence level. Now one thing you might notice here is the confidence level is exactly what you have, so you don't have to make simple adjustments. Hit calculate, and here you go. Here's your confidence interval. Here was your original point estimate, and this is your sample size. All there in one place. Watch out though, don't hit one of the keys in the middle of things. All of a sudden it'll disappear and you'll wonder, what did I do wrong? You'll have to do it over again. So when you get this set of data, write them down. There's your interval. There's the point estimate is right in the middle. You've got a left-hand side and the right-hand side for that interval. Now, here's something you ought to write down. Proper wording for an answer like this. With 95% confidence, you can say that the population proportion of U.S. adults who use Facebook is between 65.7 and 70.3. And remember, this also means that it doesn't mean your population proportion has a 95% probability of being in there. It either is or it isn't, but it does mean that if you created confidence intervals over and over and over again, 95% of those confidence intervals would contain the population proportion. 5% probably won't. Next, we'll look at another example. We're interested in 18 to 29-year-olds, and we want a 99% confidence level of what proportion of them get their news from television. So here's the television part. We don't need this, we don't need this, we don't need this, at least not right now. We could have a second one. So first of all, don't forget this part. This is the easiest thing to forget. Checking to see whether this population proportion is normally distributed or not. So N times P, Q, P times Q. Excuse me. Let's start again. N times P, N times Q, and of course those are P hat and Q hat. They're both greater than 5, so we're in good shape. It's approximately normal. Next, we'll go to our calculator, the easy way of doing it. Stat, slide over to tests. The simple way really is hitting the left arrow. That gets you there right away. We want A, 1 proportion Z interval. Put in the 216 that we got from our sample. Put in the 800, the sample size, the confidence level we want, and let's calculate, and there is our confidence interval. About 23% to 21%. And this is a reminder of what we used to get that. Just a reminder of the steps. And we don't need this. If you're using the calculator, you don't need to do this. I showed you that originally because that's what the calculator is doing for you. If you didn't have a calculator, if you'd been born, say, 50, 60 years ago, this is how you'd be doing it. You don't need to do this. Isn't that good? There's your confidence interval. And that's what it looks like on your TI-84, and probably very similar on your TI Nspire as well. So, wording. So hit pause, write that down. Get into practice. With 99% confidence, you start off with that. You can say the population proportion of 18 to 29-year-olds who get their news on television is between 23.0% and 31.0%. There is a good answer. Lastly, how do you figure out what sample size you have to have? All you need to do is take these numbers that you've got available, put them into this formula, and see what you get. Remember, as before, whatever you get, round it up to the next whole number if it isn't already a whole number. And this is only the minimum. If you're actually doing this, having more in your sample size is not a bad thing at all. It's a good thing. Round it up, as with all minimum sample sizes, because it's only a minimum. And it assumes you have the P hat and Q hat, of course. Otherwise, you couldn't do it. Now, this is important. Let's see if I can draw a star here. If you don't have P hat and Q hat, you have no idea because maybe there's no historical reference you can use, or for some reason you don't have it. Use 0.5 for both. Remember that. There will be an example most likely of this on the worksheet and on the test. And one more for the road. You're running a political campaign and you want a 95% confidence of the proportion of registered voters who will vote for your candidate or you perhaps. And your estimate must be accurate to within 3%. What's this 3%? That's your margin of error. Find the minimum sample size. No preliminary estimate. That means you're going to have a p-hat that you assign as 0.5 and a q-hat you assign as 0.5. There you go. You're ready to put it in the formula. You get the z. Remember, if you don't have a TI-84 plus CE, you won't be able to use this part. You'll have to use inverse normal. 0.975, which is 1 minus C over 2, and then subtract that from 1. That gives you this point right here, the critical Z value. But if you do have one of those, and most of you do, don't forget the 0 and the 1. Put that center in, and you can use the 0.95. Put the numbers in. Here's what we get. Remember, always bump it up for the minimum sample size. So you'd need at least 1068. How is 1100 good? Yes. This is only the minimum. Now here's a little bit of a twist on it, or more normal, excuse the pun. If you do have a preliminary estimate, put that in for p-hat instead. Also get q-hat because you know you'll need that as well. Put it in your formula. After you get the z value, you've got the e value that's given to you in the problem. And of course, round up to the 913.02 to a 914, and you're in business. Well, that's it for confidence intervals, and in particular for confidence intervals for population proportions. See you again when we talk about hypothesis testing. Bye for now.